Okay, this is the spring final review, and this is for Unit 6, so Unit 6. So for 1 through 6, we want to simplify each rational expression completely. So I'll start with number 1. So for number 1, I want to break these down into roots I know. So factors of 27 are 1 and 27 or 3 and 9. So I know the square root of 9, so I'm going to use 3 and 9. And then remember there is an implied 2 here, right? Implied 2. So then now I want to check my powers and see if they're divisible by 2. So 2 is divisible by 2, so I'm going to leave x squared the way it is. But I can't divide 7 by 2 evenly, so I'm going to just split that up. So I can peel one of those off, and that would give me 6 and 1. So I still have 7y's being multiplied here, but now I know that one of those numbers is divisible by 2. So now I'm going to go ahead and take roots of everything. So I cannot take the square root of 3, so I'm going to leave that one alone. But I can do the square root of 9, so the square root of 9 is just 3. And then I can take the square root of x squared, so when we're doing exponents we're just dividing, which is different than coefficients, right? We actually have to root them. So 2 divided by 2 is 1, so that would make this x to the first. And then 6 divided by 2 is 3, so that would become y cubed. And then I cannot do 1 divided by 2, so I'll leave that one there as well. So I have a 3 and a y that I can't reduce, can't square root. And then now once I get here, I always want to check to see, do I need any absolute values? So absolute values, if I have an even root with an even power, and it turns into an odd exponent, then I need to use absolute values. Because x squared is forced positive, but x to the first is not. So I have to force it positive if x were to be negative, and so that would make this an absolute value. Okay. And then here, so I have an even, right, x squared even power to an odd power. So here 7, this is already an odd power, so I don't even need to be concerned with it, and then that would be my answer. Okay. All right, and then let's take a look at a cube root. So for here, this is different, right, because now I want to find cube roots. So as soon as it's an odd root, I don't need to worry about absolute values, right? It's an odd root, no absolute values are to be concerned with. So I cannot do the cube root of 24, so I need to think of numbers I can cube root. So 24 could be 2 times 12, I don't know any of those roots, cube roots anyways. It could be 3 times 8, and I do know the cube root of 8, so I'm going to use 3 and 8. And then 6 is divisible by 3, so I'm going to use leave the m to the 6 alone. But 5 is not divisible by 3, so if I were to take off just one of them, that leaves 4 and 1, neither of which is divisible by 3. So I could split it up to 3 and 2. Okay. And so now let's go ahead and root each of those. So I can't cube root 3, and the cube root of 8 is 2. And then 6 divided by 3, so I divide my power, so 6 divided by 3 is 2, so m squared. And then 3 divided by 3 is 1, so that would be n to the first. And 2 does not divide by 3. So then what I cannot reduce or simplify is 3n squared, so that stays inside the root. And that would be my answer. And then, of course, I don't have to have the n to the first power, right? I can just write that as n. Okay. And then let's take a look at number 5. So for number 5, I'm going to rewrite this as a radical. So let me just start with my bases. And so I have a root of 3 and a power of -1. So root of 3 and a power of -1. So the cube root of 64 is 4, right? Because 4 times 4 times 4 is 64. And then 9 divided by 3 is 3, so that would be x to the third. And then that's raised to the -1 power. So to the first power, that's not going to change anything, right? That would just be 4x cubed. But because it's negative, that means it's going to be 1 under. So it'll be 1 under, or excuse me, 4x cubed under 1. I said that kind of weird. So 1 over 4x cubed. Okay, and then let's take a look at number 7. So let's do 7 here. So this one here wants us to, multiply it, and then once we get it multiplied, they want us to simplify it. So we're going to start with just multiplying. So watch that we're doing the 4th root here. So I want to just do 8 times 4. And then when I'm multiplying these, this means I have 3 x's multiplying to 6 x's. So altogether, that means I have 9 x's being multiplied. Here I have 3 y's being multiplied to 1 y. So altogether, I have 4 y's being multiplied. So then once I get to here, I want to see, okay, can I, take the 4th root of any of these things? And I can't, right? I can't take the 4th root of 32, and I can't do 9 divided by 4, but I can do 4 divided by 4. So 32 is 2 times 16, and I do know the 4th root of 16. And then 9 is not divisible by 4, so I'm going to take just 1 off, because that would leave me 8, and 8 is divisible by 4. And like we said, the y to the 4th is fine. So I do not know the 4th root of 2, but I do know the 4th root of 16, which is just 2. 1 is not divisible by 4. But 8 is, so 8 divided by 4 is 2, so that would be x squared. And then 4 is divisible by 4, which is 1, so y to the 1st. And then the only thing I can't reduce or find to the 4th root of is 2 and x. And that would be that. Okay, so let's go ahead and take a look at number 9. So I want to be able to subtract these, but I can't subtract them right now because these are not like terms or not like radicals, so I need to make that happen. So I'm going to simplify first and then subtract. So I don't know the square root of 75. But 75 is 25 times 3, and I do know the square root of 25. And then m, I can't make any better than that. And then I can't, these are again 2's here, so I can't divide 5 by 2, so I need to break that apart. So I'm going to make that into the 1st and into the 4th. And then I'm going to do the same thing on this one. So for 48, that is, what can we do here? About 16 times 3, and then the 3 is not divisible by 2, so I'm going to break that up to m to the 1st and m squared, and then n can't go any smaller, so that'll stay the same. So the square root of 25 is 5. Can't do that, or that, or that, and then I can divide 4 by 2, so I'm going to do 4 by 2, so that would be n squared, right? And then this is what I can't reduce or simplify. So then the square root of 16 is 4. Can't do that or that. And then 2 divided by 2 is 1, so that'll turn into 1. And then I can't do anything with that. So then I'm left with the 3, m, and n. And then I'm going to go ahead and multiply these together. So that would be 5 times 4. And then m n squared, and then 2 times 4, and then put them in alphabetical order there, by the way. Okay, so now that I've reduced them completely and combined my leading coefficients there, I can now go ahead and combine. So I'm just subtracting here, so I'm just going to do 20 minus 8, so that means I have 12 mn squareds altogether, and a root of 3 mn. So again, all I'm doing is subtracting my leading coefficients. Everything else is staying the same. Okay? All right, let's take a look at the next page. So we're going to do some graphing. So let's go ahead and take a look at number 12. So for this one here, we want 2 graphs. So I'm going to go ahead and add the 3 to the other side, just to get that grouped correctly. So g of x is just the same as y. Oops, that's not cube root, that's just a 3. Okay, so my start is at -4, -3, so -4, -3. So I'm going to go left 4 and down 3. And then I have a stretch of 3, so I'm going to go up 3 and over 1. And I know I have to find my x and y intercepts, so I'm going to go ahead and do that before I finish graphing, which you did not see at all. So let me zoom out. Okay, so what I just did was, so I got my start was at -4, -3, so alphabetical order, opposite on both, so I went left 4, down 3. And then my stretch here was 3, so from my start I went up 3 over 1. So I now have to find my x and y intercept, so I'm going to go ahead and find my y-intercept first so I can have a more accurate graph here. So to find the y-intercept, that means I need to solve for y, so I need to get y by itself. And the only way to do that is if x were 0. So I'm going to go ahead and let x be 0 right now, so I can go ahead and find that y-intercept. So I will have y plus 3, and then equals 3, oops, I keep on making that the cube root, and then replace x with 0. So 0 plus 4 is 4, so I would have 3 times the square root of 4, and the square root of 4 is just 2, so 3 times 2 would be 6, and then minus the 3 over. So y would equal 3. So let's go ahead and do that. 1, 2, 3. And so then there's my graph. Those. Okay. So now I can see that my x-intercept is -3, but it's not always as obvious as that. So I'm going to go ahead and solve for it just to get you exposed to that again. So it's, you know, clearly it's at -3, but we're going to solve it. So if I want my x value, that means I need to get rid of the y in order to solve for the x. So I'm going to let the y be 0. So I'm going to let y equal 0 so I can find my x-intercept, so I can solve for x. So y would be 0, and 0 plus 3 is just 3. And so to isolate the x, I want to divide by 3. And 3 divided by 3 is just 1, and 1 times that isn't going to change anything. And then now to get rid of the square root, zoom in just here. I want to square both sides, get rid of the square root. So 1 squared is 1, and then that'll cancel. And then subtract 4 from both sides. And there's my x-intercept, which we already knew was -3 just by looking at the graph. Okay, so let's go ahead and backtrack just a little bit. We want to find domain and range. So for the domain, that's left comma right. So we want to look to see, okay, how far left is the graph going? And so the farthest point the graph goes to the left is at this dot here. So where is that at? 1, 2, 3, 4. So the farthest left was -4. And then the farthest right is forever, right? Because it's a little arrow there pointing to the right forever. So positive infinity. And then what's my lowest point? So here's my lowest point on the graph, and that went down 3. And then as far as my highest point, so although this arrow looks like it's pointed to the right, remember it's really pointed in 2 directions, right? So in this case, it's not just right, it's also going up a little bit. Like not much, but it's going upwards. And so upwards forever eventually, and so that would be positive infinity as well. So your domain, remember, is left comma right, so from -4 to positive infinity. And so the -4 is a closed dot, so that would be a bracket, and infinities would be parentheses. And then the range is just bottom comma top, so that would be -3 to positive infinity, and bracket on the -3. Okay. All right, and then for part C, we are looking for the open interval where g of x is greater than 0. So that just means above the x-axis, right? So we're just looking for where is it above the x-axis, right? Because when is your y value greater than 0? That's when you're above the x-axis. And open interval, remember, means left comma right on the interval. Open mean use parentheses. Even if it's a closed dot, use parentheses open. Interval left comma right. So I want to look to see where is it above the x-axis. So I'm just going to highlight that so we can see that. So where is my graph above the x-axis? And that's on this section right here, right? And so again, we're doing open, so parentheses, and then interval, left, comma, right. So left, so how far left? So 1, 2, 3. So that would be from -3. And then highlighted forever to the right, so that would be positive infinity. And then that, again, that was where g of x was greater than 0. And then now for where is g of x less than 0, well, that's the rest of the graph, right? Because the rest of it is where is it below. So this would be where are we below. Okay, so that would be this section here, right? So I'm just going to use a different color there so you can see that. Okay, so where is that below the x-axis? So for g of x less than 0, so again, left, comma, right. So how far left? So the farthest left it goes to is this dot, and that was at -4. And then the farthest right is at that dot, which is at 1, 2, 3, -3. And then because it said open, parentheses on both. Okay? All right, and let's take a look at a cube root problem. So we'll do number 13 as well. Okay, so for this one here, so again, I'm going to go ahead and put this in the standard form. So I'm going to subtract 4 from both sides. And h of x is the same as just y. So for this one here, I'm going to just graph it and then do part C. So I'm not going to do A and B, but I'll graph it and then do part C. So to graph it, so my start would be at +1, +4, and then my stretch is just 1 over 1. So I'm going to go to 1, 4, so over 1, and then up 4. And then my stretch is 1, so I'm going to go up 1 over 1. So now remember, for a cube root, it starts out looking like your just normal square root. So it'll go like that. But then it can be negative, right, because we can take the cube root of negative. So that means we can go to the left as well. So to go to the left, we're just going to use the stretch again. We're just going to do the reverso. So we're going to go down and left. So we're just using symmetry. And so the cube root graph looks something like that. And then I would actually look for my x-intercept as well, just for accuracy, but I'm not going to do that for this video. And then let's take a look at part C though. Oops, hold on, my lights just clicked out. There we go. Okay. So for the average rate of change, so remember these are my x values, and I need to find their corresponding y values. So I know that x is equal to 1, so I'm going to do that right here. So I'm going to replace x with 1 and then solve for y. And I'm going to use it from the original equation, so I don't need to worry about moving that 4 back over. So all I'm doing is replacing x with 1, and h of x, remember, is just the same as y. So 1 minus 1 is 0, and the cube root of 0 is just 0. So y would be 0 plus 4, which is 4. So my ordered pair was when x was 1, I got a result of 4. So there's one of my ordered pairs. So now I need to do the same thing again, but I'm going to do it for 9. So again, I'm just going back into the original equation. So I have it scooted up so you can't see that. But all I'm doing is replacing the x from the original equation with 9 this time instead of 1. So this will be the cube root, and then 9 minus 1, and then plus 4. So that would be 8. So 9 minus 1 is 8. And the cube root of 8 is 2. So this is 2. And 2 plus 4 would be 6. So my y value is 6, and that was because I used 9 for x. So when x was 9, my y value was 6. So now that I have my two ordered pairs, now I just need to use my formula for finding the average rate of change. So average rate of change is when I just subtract my y values over my x values. So again, to find my average rate of change is just delta y over delta x. So I'm subtracting my y values over my x's. So my y values are 4 and 6, so I'm going to subtract those. So 4 minus 6, let me go this way here. And then now I want to subtract my x values. So my x values, I want to go in the same order that I went, right? I can't be going 4 minus 6 and then go 9 minus 1, right? I got to go the same order. So now I'm going to do 1 minus 9. And I could have done it the other way, right? I could have done 6 minus 4 on top, 9 minus 1 on the bottom. It really doesn't matter which way I subtract. Just whichever way is good for you, that's the way you need to run with. So then 4 minus 6 is negative 2, and 1 minus 9 is negative 8. And then I can divide by 2 to reduce it, and that double negative will turn positive. Excuse me. So 2 divided by 2 is 1, and 8 divided by 2 is 4. So there is my average rate of change. Okay? All right, and one more page for Unit 6. So let's take a look at some solving. So let's look at number 15. So for number 15, I want to solve for x algebraically. So that means I need to isolate the x, get it by itself. So I need to get rid of the 17, the 4, the square root, and the 8. So I can't combine 17 minus 4 and make that 13 because 4 is not subtracting from 17, it's actually multiplying the radical. So again, and I'm trying to isolate. So I'm going to subtract the 17 first. And then divide by negative 4 since it's multiplying. Remember the radical because it's side by side, so that means it's multiplying. And that's positive 9. So again, remember we're trying to isolate the square root, or isolate the square root first, and then now I want to get x by itself. So before I can square both sides, though, I need to make sure, can I actually square both sides? And so can a square root equal a positive 9? Of course, right? Square root of 81. And so then that means I can go ahead and square both sides. So cancel. So x minus 8 equals 81. And then one last step here, add 8 to both sides. So x would equal 89. And that would be my answer. All right, and then let's take a look at number 17. So again, we want to solve for x. So I still need to isolate the radical. So I'm going to subtract the 4 from both sides. And then once I do that, I want to square both sides. So this one's going to be difficult, right? Because I have an x on both sides, so that is going to require some extra work. So I'm going to square both sides, and that will cancel. And then over here, though, because this is square, that means I have 2 of these, so I'm going to write that out twice. And then in order to solve this equation, I'm going to have to distribute and eventually use the zero product property. So let's go ahead and distribute first. I'm going to multiply the x to both of these. And then the negative 4 to both of those. And then let's go ahead and combine like terms. So I'm going to combine the negative 4x's together. So I have to have this equal to 0 before I can group it, right? So I need to equal this to 0. So I'm going to subtract x and add 2 to both sides. So it's equal to 0. And then I want to go ahead and group this. So let me do this over here because I'm running out of room. So factors of 18. So for that I can use, see, 1 and 18, remember I'm trying to get negative 9 here, or 2 and 9, or 3 and 6, so it'll be 3 and 6, and then I want it to be a positive 18, so they're either both positive or both negative, and they'll both be negative because that's a negative, so that would be negative 3 and negative 6. And so then now when I go ahead and solve, so I'm going to just split that. So I would let x minus 3 equals 0. So x equals 3. Oops, not 0. And then x minus 6 equal to 0, so x would equal 6. So I know that the x value is 3 or 6, but only one of those is actually going to be my solution to the original equation, right? So, and I'm just going to write over here what that is. So this is when I had isolated the x right before I squared it, right? So I'm just rewriting it again just so it's right by where I'm looking. So this was right at the beginning, so let me backtrack just a little bit. So that was right here. So after I got the radical by itself, so all I did was copy that portion down again. So what I'm looking for is I want to make sure that the square root will equal a positive number, right? And if not, then I have an extraneous solution. So for example, if x were 3, I would get 3 minus 4 is negative 1. And can a square root equal negative 1? No. So what about 6? If I let x be 6, 6 minus 4 is 2. Can a square root equal positive 2? Of course. So my actual answer to the square root problem is x is only going to be 6. Okay? And then let's take a look at the last two, number 19 and 20. And so this is when I want to rationalize the denominator. So I know it says simplify the expression, but what we're doing is we're trying to rationalize the denominator. So in order to do that, I want to multiply the top and the bottom by the square root of 2y. And then when I multiply radicals together, that leaves me with just 2y, right? Because just a reminder, that means I have two of those, right? So I have root 2y multiplied by itself, so meaning squared, right? So that is the same as this. And then the root and the squared are inverses, leaving me with just a 2y. And then from here I'm usually done, but I want to look to make sure I can reduce anything. So I can't reduce here because this is a radical, this is not. So I need to try to look to see, can I reduce anything here? And I can, right? Because 4 and 2 will divide. So that'll be a 1, and then that'll be a 2. So I'm left with 2 root 2y, and then over 1 times y, which is just y. Okay. And last one here, number 20. So this one is not like number 19 because this only has the radical in the denominator, and that's the only term. But here I have two terms, the 5 and the 2. So I can't multiply top and bottom by square root of 5, because if I did, I would have to distribute it to the 2, leaving the radical down there still. So this was the one where we had to multiply by the conjugate. So the conjugate, remember, is instead of a subtraction problem, it would turn into an addition problem. And then these are conjugates. So one adding and one subtracting. And whatever I do to the bottom, I have to do to the top. Okay. So, whoops. Okay. So for here, normally what we would want to do is not distribute the top because we would just end up having to factor to try to reduce it. So I can not distribute that. But most of us would actually forget that. So I'm going to go ahead and distribute because that's what we're just used to doing. So even though normally we would not want to, we'll probably forget. So I'm going to go ahead and distribute that in. So I can't multiply it to the 5 because this is a square root, this is not. So this would just be side by side. So that would be 6 root 5. Oops, and I wrote 15. How about 5? And then 6 times 2 is 12. And then let's distribute the bottom. So the root 5 needs to multiply to both of those. So that would be the square root of 25. And then 2 and the 5 can't multiply, so I'm just going to write them side by side with the rational number first, irrational second, and then distribute the second one. So negative 2 needs to multiply to both of those. And then that cancels. And then the square root of 25 is just 5, and 5 minus 4. Which is just 1, right? And I don't need to write over 1. And that would be my answer. Okay, and that's it for the Unit 6 Spring Review.